Okay, so this is Algebra 1, Lesson 6.3. We're going to look at solving systems by elimination. So we've looked at solving systems by graphing, and then the other day we looked at, before break, solving systems by substitution. So now we're going to look at a third way, solving systems by elimination. So we're going to do our warm-up first. So we're going to add like terms in this case, and if you notice, we have a positive 2y and a negative 2y. So those will cancel. It's not that one. And we're left with 3x and negative 5x, which is equal to negative 3 or negative 2x. Okay, first we need to distribute this. So we're going to rewrite that as 5x minus 5y. Make sure the 5 gets distributed to all parts. You guys forget to do that a lot. And then this 5y and this 5y will cancel because one's positive, one's negative. So we're 5x and 2x becomes 7x. Okay, same thing on the next one. We need to distribute first. So we've got 4y plus 6x minus 3y. And now this negative distributes to this 2, so we have negative 6x. Our x's cancel because they're opposite. So we have 4y minus 3y. We're left with a single y. Okay, again, distribute. 2y minus 4x. Now, minus 8y. And then we have a negative 2 times a negative 2, so that becomes a positive 4x. Our x's cancel. We're left with 2y and negative 8y, which is negative 6y. Okay, the second part of the warm-up says to find the least common multiple. That means the smallest number that both of the numbers listed can be divided into. So between 3 and 6, we need to find the number that both of them can be divided into. And the smallest number is 6 because 6 goes into 6 one time and 3 goes into 6 two times. Okay? For 4 and 10, the smallest number they both go into is 20 because 10 can go into 22 times and 4 can go into 25 times. For the next one, here's what I like to do. I like to start by doubling the bigger number and seeing if the smaller number can go into it, if the smaller number can't go into the other number. So if I double 8, 8 times 2 is 16. That means 6 cannot go into 16. 8 times 3 is 24. That means 6 does go into, so 24 is the smallest. For our next one, again, if one number can't go into the other, excuse me, yawning. We're going to double the bigger number, so 10. If the other number can go into that, then that is our least common multiple. So we're done. So like I said, we're going to look at solving systems of linear equations by two variables by something called elimination. Okay. Another method for solving systems of equations is elimination. Just like substitution, the goal is to get rid of one of the variables so you only have one variable left to solve for. Remember that an equation stays balanced if you add equal amounts. Sorry guys, I don't know why I'm running. If you add equal amounts to both sides. So for example, if I have the system x minus 2y equals 19 and 5x plus 2y equals 1, 5x plus 2y equals 1, that equals each other. So we can add 5x plus 2y to one side and 1 to the other side. The reason is they're equal. This is equal to this, so I can add one of it to one side of this first equation and the other part to the other side, and I'm not changing the equation. Okay, so for example, we're adding 5x plus 2y to the one side of the first equation and 1 to the right side of the other equation. Because 2y and negative 2y are opposites, they just cancel, and we're left with just those x's. So 6x on this side equals negative 18 on that side. Then it makes life a lot easier to solve. Okay, so the main thing with this that we're going to do is we're going to line up all of our variables and we're going to try to eliminate one of them. So first step you want to do is you want to write the system so that the terms are aligned. And then you're going to eliminate one of the variables and solve for the other one. Once you've solved for one, you're going to substitute it back into one of the original equations like we did with substitution and solve for the other variable. And then you can write your solution as an ordered pair, x comma y. And later in the lesson, we're going to learn how to multiply one or more of the equations by a number in order to eliminate one of the variables. So we'll look at that later. So here's how this works. Okay, you start by lining up your terms. So our x's are lined up, our y's are lined up. and our coefficients are lined up, or not our coefficients, our constants. Now we can add the equations together. So we're just adding like terms. Well, if you notice, the 4y's are opposites, so they cancel. So we're just adding 3x and x, which becomes 4x. This went away, and now we're adding 10 and -2, which becomes 8. Now life's a lot easier. We can just solve for x. X is equal to 2. Now to solve for y, we plug this back into one of the equations. It doesn't matter which one. I'm going to pick the second one. So x plus 4y equals -2. I'm going to plug 2 in for x. I'm going to subtract 2 from both sides. So I get 4y equals -4. Divide by 4, and y is equal to -1. So our solution is 2, -1. And the way to check it, remember, if I ever say to check, is that you plug the x and the y value back into both equations. When two equations each contain the same term, you can subtract them also if you need to. To subtract them, you add the opposite of every term in the equation. So let's look. Okay, if we were to add these, nothing cancels. However, if I subtract the second equation from the first, that means I've changed the sign of everything in the first. Then I can get the x's to cancel. I'll have a positive 2x and a negative 2x. Now those go away, and I'm left with y plus 5y. So that becomes 6y. A -5 and a -13 become -18. Now I can divide both sides by 6, and y is equal to -3. Now I need to plug that into one of the equations. I'm just going to pick the first one. I need to plug in the -3 into y. I need to move that over. 2x equals -2. Divide both sides by 2, and x is equal to -1. So my solution is -1, -3. Okay, remember to check by substituting the answer into both the original equations. That's going to tell you if you've got the right answer. In some cases, you're going to need to multiply one or both of the equations by a number that one of the variables has the opposite coefficient of, so that you can cancel one of the terms. So we're going to look at that now. Okay, so we've got x plus 2y equals 11 and -3x plus y equals -5. Well, right now, nothing cancels. I don't have the same of anything, but I need to get the same of something in order for it to cancel. If I could have positive 3x in this first equation, I could cancel my x's. But if I'm going to make that a 3, I need to multiply everything in this original equation by 3. So my new equation is 3x plus 6y equals 33. So if I change one part, I've got to change all of them. I'm going to rewrite the other equation right below it. And now, if you notice, these cancel. So I'm left with 6y and y, so that's 7y. 33 and -5, that will become 28. If I divide both sides by 7, y is equal to 4. Now to solve for my x, I'm going to take one of my original equations. I'm going to take the first one before I changed it. I'm going to plug in my value of y. X plus 8 equals 11. If I subtract 8, I will get x is equal to 3. So my ordered pair is 3, 4. Okay, so if you guys notice, that was multiplying by something to get rid of another one. Okay, now both equations here. Now if we look, nothing cancels. So this is where I'm going to have to use something called the least common multiple. So a number, the smallest number that they both go into. Well, I'm going to start by getting rid of the x's. You could totally get rid of the y's also. It doesn't matter which one you get rid of. I'm going to do the x's since they already have opposite signs. If I can make this 10x and this 10x, because that's the least common multiple of 5 and 2, then they can cancel. So in order to make this 10x, I need to multiply the first equation by 2. So I'm going to rewrite this as -10x plus 4y equals 64. Now, in order to make the second equation 10x, I want it to be the opposite sign. I'm going to multiply by 5. So this becomes 10 x, because 2 times 5 is 10. The 5 times the 3 becomes 15y. And then the 5 times the 10 is equal to 50. Now, when I combine, these cancel. The 15 and the 4 become 19y equals 114. I know that's a big number, but if you divide, you'll get that y is equal to 6. Now I can plug that back in. I'm just going to pick the first equation since it's the first one written. So then 5x plus 12 is equal to 32. If I subtract 12 from both sides, I get negative 5x equals 20. Divide both sides by 5, negative 5, and x is equal to negative 4. So my solution is negative 4 comma 6. So in this case, I had to use the least common multiple and figure out what to multiply each equation by to get rid of one of the terms. Like I said, I could have gotten rid of the y's, so I probably would have multiplied the first equation by 3 to make that 6y, and the bottom equation, I would have multiplied it by 2 to make it 6y, and then you would have had to subtract the equation. So, okay, so we've got one little example, word problem here. So Paige has $7.75 to buy 12 sheets of felt and cardstock for her scrapbook. The felt costs 50 cents per sheet and the cardstock costs 75 cents per sheet. How many sheets can Paige buy? We need to write a system, and it tells us to use F, the variable F, for the number of felt sheets and C for the number of cardstock sheets. Well, a system needs at least 2 equations, so we need to come up with 2 somehow. Well, the first one's going to be an equation that tells us the cost of the felt and the card stock together will equal $7.75. Well, to write that, I know that 50 cents per card plus my 75 cents per felt, all of that together has to equal $7.75. So 50 cents times every piece of cardstock I buy plus 75 cents times every piece of felt that I buy, the total is $7.75. My second equation is going to be based on the fact that she can have 12 total things, okay? So C plus F, the cardstock plus the felt, she can only have a total of 12. So my 2 equations are 0.5C plus 0.75F equals 775, and C plus F equals 12. Okay, so let's write those 2 equations again. 0.75 times our F. Was it F or was it C? Oh, I should have flipped these. Sorry about that, guys. This should be F. And this should be C, because the cardstock's 75 cents. I'm just making them in line. It's the same concept, I just had them flipped. Okay, so 0.5F plus 0.75C equals 775. And then F plus C equals 12. Well, in order to get rid of one of these, I'm going to multiply the second equation by 0.5. Because when I do that, I'm going to get 0.5F plus 0.5C, and then half of 12, 0.5 times 12 is 6. So now this equation and this equation is what I'm going to use. If I subtract this one from the top one, that's how I'm going to get rid of the F's. So if I subtract 0.5F from 0.5F, I'll have no F's left. If I subtract 0.5C from 0.75C, I'll have 2.25 left. And if I subtract 6 from 7.5, I'll have 1.75 left. Now, how many times does 25 cents go into $1.75? This you should be able to do. C is equal to, anybody know? Okay, 7. 25 goes into $1 4 times, and then 25 goes into 75 cents 3 times. That's where you get the 7. Now, this is kind of simple because we know that F plus C equals 12. So if C equals 7, then F has to equal 5. So our F is equal to 5. Therefore, Paige can buy 7 sheets of cardstock and 5 sheets of felt. Okay, just remember that all systems can be solved in more than one way. You might find one system way to solve better than another. So again, we looked at graphing in the first lesson. Substitution was where you plugged one into the other one, and then elimination is this one we just did where you're subtracting or adding to get rid of variables. So it's your choice, whichever one works better. We've got a few last examples. I'm going to give you guys the answers, and I would like you to go ahead and try these and then check your work. So go ahead and pause. Make sure that if you don't get the right answer, you ask me how I got that so we can go over it. For the first one, you should get that x is equal to 11 and y is equal to 3. For the second one, you should get x is equal to 2 and y is equal to negative 3. And for the last one, you should get x is equal to negative 3 and y is equal to negative 7. So just go ahead and try those, ask if you don't get it, and I can go over them. And that's it.